In the 1970s, advances in computer design meant that companies could move from big single mainframe computers to smaller, multiple mini and microcomputers. Since it was no longer held centrally, exchanging data between computers became problematic. Initially, this was done by copying files onto a floppy disk and then taking that disk to another computer where the data was copied onto. It became obvious that a better way of exchanging data between computers would be by a direct connection between them. When computers are connected together, they are called a network. Here, each computer had a dedicated circuit board to which a cable was attached. Software in each computer controlled the sending and receipt of data. This was fine for two computers, but it meant that for each new computer you needed another circuit board and cable add-in. Eventually, the need to share resources such as data storage and printers meant a better way of connecting was needed. In the late 1970s, the first local area network, or LAN, came into use. Here, rather than connecting each device directly to one another, each device is connected to a central switch through which they can communicate, and this was the start of today's interconnected world. A network is formed when we connect two or more computers or devices together with the purpose of exchanging information or sharing resources. There are many types of networks, all having the same basic function, but which differ in terms of how big they are, who owns them, as well as how and where the data flows. Let's have a look at some of these different types going from small to big. Here we have two examples of a personal area network, or PAN, where the devices are personal to the individual and are physically close to each other. The mouse talks to the computer using proprietary radio frequency wireless technology, whereas the headphones and smartphone talk to each other using something like Bluetooth. Here's a local area network, or LAN. A network is called a LAN when we're connecting users who work together and are local to one another in a home or office. A LAN can have many hundreds of computers and shared resources such as printers. LANs are usually owned by a single individual or organization, such as a company. When you need to connect devices potentially thousands of miles apart and owned by different organizations, the network is called a wide area network, or WAN. Logically, WANs connect LANs together, and the connections are usually leased from telecoms companies, such as when you use a broadband service. Finally, we have the Internet, which is the overall network connecting all WANs worldwide. How the devices on a network are connected together is known as the network's topology or shape, and there are a number of different topologies from which to choose. We'll look at four types: bus, ring, mesh and star, but only from a logical view rather than how these are physically created with cables and connectors. A really simple way of connecting our network of devices would be to use a single length of cable called a bus and connect each device to it. When a device sends a signal or data down the cable, a number of things can happen. First, all other devices will receive that signal whether it's intended for them or not. Secondly, the signal will bounce back along the bus when it reaches the end. And third, signals can get mixed up if two devices send something at the same time. Of course, we don't want every device to receive everyone's data, so we make it a rule that a device ignores data that's not intended for it. To solve the bounce back problem, we add something called a terminator to each end of the network. Its job is to absorb the signal once it reaches the ends of the network. Stopping collisions is more difficult, and is mostly achieved by a set of steps that each device carries out. The first is only to transmit if the bus is quiet, and doing so immediately. When transmitting, it monitors the cable to see if a collision has occurred, then it stops transmitting. It then waits for a small but random amount of time before attempting to retransmit. Whilst bus topologies use less cable than other forms, their big disadvantage is that the whole network fails if the bus cable fails. This and the limitations of speed mean that the bus topology is not commonplace now. Another way of logically connecting devices together is to connect one directly to another in a loop or ring topology. With this arrangement, we don't have a terminator bounce back problem, although the other two problems still exist. Ring topology networks get around these problems by using a token passing system. For example, to send a signal from device 1 to 3, it must pass through 2 or 4 first. They do this by passing an empty token around the network, which is acquired and filled by a device when it wants to send data, and emptied by the device who it's intended for. Devices that the signal was not intended for simply ignore it. Since devices don't send signals at the same time, as they are just examining a token, the problem of collisions doesn't exist. And the benefit of the ring technology is that they behave predictably, and as such are tended to still be used in areas such as industrial automation. Their disadvantage is that there is greater work needed in processing the tokens. Another network shape is to directly connect each computer to one another. This is a mesh technology. Whereas this layout gets around all of the problems outlined previously and is therefore reliable, it requires lots of connections. For example, 4 devices need 6 connections and 20 devices need 190 connections, so it's therefore very expensive to build a mesh topology. Mesh networks are used in WANs for reliability and performance reasons. Finally, a star topology is when all computers are connected to a central point called a hub or a switch, forming the shape of a star. A hub or switch accepts signals from a sending computer and delivers it to its destination computer. Hubs and switches are distinct from one another. Whilst the job of both is to pass signals around the network, a switch knows about the computers connected to it. A hub doesn't, and simply sends each signal to all computers connected to it in much the same way as a bus does. Star topologies are reliable in that the failure of any connection doesn't affect the rest of the network, and since each device has its own connection to the central switch, collisions don't occur, as the switch orchestrates the movement of data between devices. So now we know something about the different sizes and shapes of networks, we can turn to the problem of how you can link your computer to exchange data with any other computer in the world, which is of course the Internet. The first thing to note is that computers can only exchange data if they obey the same rules and procedures to do so. These rules and procedures are called protocols, and the ones used by the Internet are called Transmission Control Protocol, Internet Protocol Suite, which is commonly abbreviated to TCP/IP. In the early days of networks, a particular problem was the size of the data one computer could send to another. Given that a computer had to wait for the network to be empty before sending its data, big messages caused every computer to wait until it had finished. The solution was to limit the amount of data that a computer could send at any one time by breaking large messages into smaller pieces and then sending them separately. These smaller pieces of data are called packets. Each packet contains a sequence number so that the receiver knows how to put each piece of data back in order to form the original message. This one's number 3. So how do the packets actually get from one computer to another? Firstly, each packet contains the address of both the sender and receiver computers so that it gets to the right one and replies are sent back correctly. What is an address? Well, it's the way of uniquely identifying the network controller for a device. We'll look at addressing and protocols in another video, but for the moment just assume that the address identifies a device, in much the same way as your home address uniquely identifies where you live. Knowing the address of the sender and receiver is fine, but the network needs to know how to get the data from one to another. In other words, it needs the route between them. Not surprisingly, this is done by something called a router. A router's job is to connect networks together and then to forward a packet onto its destination, much in the same way as a postal service determines the best way to get a letter to its recipient. Of course, if you just have a LAN and don't want to connect to anything outside of it, you don't need a router, but for access to the Internet you do. In this case, your router acts as a gateway to the Internet and is used to connect to your Internet Service Provider network or ISP. The job of an ISP is to provide a way of moving packets onto their destination network. There's a hierarchy of ISPs, with some providing local services up to those connecting countries. The Internet, therefore, is really a network of networks where thousands of networks are connected together by routers. Each time a packet is sent over the network, the device puts the data inside a network packet with the address of the next router in the header. When it arrives, the router opens the packet, examines the destination, and then picks the next router in the path and sends it on. This occurs until the packet reaches its final destination. So there we have it. We've looked at how networks have evolved from people needing to exchange and share information to the modern day Internet. Along the way, we've seen that networks vary according to size, ownership, and purpose, and that they are built from very different technologies. We've seen how a network can be configured in different topologies, each with its advantages and disadvantages. Finally, we've seen how the internet is really a network of possible quite different networks joined together by routers, which together appear as a single place. In later videos, we'll look at the more advanced concepts of computer networks and the actual technologies that underpin those concepts. But for the moment, that completes our brief introduction, so do subscribe if you'd like to know more.